So system message is once again the overall behavior of your system. User message is where you're giving specific instructions what to do, and assistant response is whatever response the assistant is giving in the process. These are the three different types of things we saw. And then there is something called prompt parameters. Okay, and there is something called prompt parameters, and we'll talk about it. And the most important parameter that we have, there are a lot of prompt parameters that we have, and one of the most important parameters that we have here is something called temperature. So temperature is a particular setting that you can control to introduce variability in the language model. Okay, so we can effectively use the temperature parameter to introduce variability in the language model. You can decide and you can introduce uh, the amount of variability in the language model based on the temperature parameter. So this is an important thing to basically keep in mind, what the temperature parameter actually does. You can actually see the screen. It very beautifully demonstrates what the temperature parameter actually is doing behind the scenes. All of you can see this. So what exactly is the temperature uh, parameter doing? And you can see that when the temperature is 0, the responses are all the same. That means there is absolutely no variability. Okay, so when the temperature parameter is close to 0 or when it is exactly 0, you can see there is no variability. So we are not having any variability at all when the temperature parameter is 0. But as the temperature parameter is close to 1, you can see that we introduce more and more variability. So temperature is just a way to introduce variability in the language model. Okay, so you can see this one generally. Um, so there are a lot of actually articles. There's one of these simple article that talks about it very nicely. You can see. So this is another a small article that talks about it. So you can see talks about what temperature actually is, and generally speaking, you can see when we take temperature equal to 1, temperature 1 means very high variability. Temperature equal to 1 basically means the variability of the language model is very high. And in a way, what it means is um, there is more probability of the next word. Okay, so there is higher probability. I mean, so it's kind of like saying that when temperature is equal to 1, you can see that the word forest is 60% probable, the word kingdom is 20% probable, and the word world is 10% probable. So there's more variability. Lot of variability is there. Okay, so as you increase the temperature value, okay, so let me just repeat myself what I'm saying. As the temperature is lower, see when the temperature is 0.5, or even better, if the temperature goes towards 0, the word forest is having the highest probability. Remember, I told you one very important thing I talked about was that all these LLMs are basically completion engines. They're basically completion engines, word completion engines. You are looking at a sequence of words and trying to predict what is the next word. And when the temperature value is very low, what it does, it always chooses the word which has the highest probability. That is, in a way, how these language models are supposed to work, right? So, based on the sequence of words, turns out the word forest has very high probability. Okay, so this will always be chosen because it is 80% probability. Every time you run the code, this will always be chosen. This is exactly what I wanted to demonstrate here. If the temperature is low, if you say the overall experience was what, so the positive word will always come because the word positive has the highest probability, if you see. But as we increase the temperature value, as the temperature value goes from 1 to 1.5 to 2, the probabilities become more uniform. Can you see? I mean, this is a bit mathematical. They use softmax functions and all that, but so this is because a higher temperature leads to a flatter probability distribution, giving lower probability events a higher chance of getting selected. Okay, I think this pretty beautifully explains what we are trying to do. So you can see that here the word forest was extremely likely. So most of the time the word forest will always come. But as you increase the temperature, you increase the variability. So even the less probable words like the word world, the word garden, which otherwise would never have made to the output, now they also have equal probabilities. So that is how we are able to introduce more variability through temperature. And mathematically, what they do is, this is the softmax activation function. This is again mathematical. So I mean, so what happens is the output probability is predicted using softmax. Some of you who are coming from deep learning, you might know what's a softmax activation. This e to the power x by summation e to the power x. And what they do is they actually, the randomness is controlled mathematically by adjusting the temperature parameter, the capital T. So instead of doing e to the power x, we do e to the power x by T. And you can see this is how we kind of modify the probabilities here. So as you increase the probability, mathematically, as the probability increases, denominator increases, so the value decreases, and e to the power of the value decreases. So you can understand what's happening here. So the weights are actually reducing here in a way. Okay, so this is what happens behind the scenes with temperature. And as the temperature is equal to 1, you can see that sometimes the output will be positive, sometimes it will be negative, sometimes it will be magical. Now you can have a question. You can have a question, okay, why is this relevant? Now, why would I ever want to do something like this? Why would I ever want to have a variable output? Well, this is mostly for creative use cases. If you're working on a creative use case, we're talking about creative generation, like writing an article, writing a post. When we talk about lots of creative use cases, this will be very, very relevant, especially when you're working on lots of creative use cases. This will be very, very relevant, where we want to effectively use a higher temperature value. And if we use a higher temperature value, we will get more varied results. So sometimes it will be positive, sometimes the generated result will be different, sometimes the mail will be written differently, sometimes the post will be written differently, and so on and so forth. Okay, whereas temperature 0 is usually not 0, but something very low. A low temperature setting is usually chosen for applications which are more factual in nature. Let's say in your enterprise you want to create a system, some kind of a customer documentation engine, where based on the customer's request, you want to document some things. And that is what we will do for when we will have a comparatively lower temperature value. So for very factual applications, the temperature should be low, whereas for more creative applications, we should have a higher temperature value. And all these parameters kind of do the same. So more top P is also something very similar. So top P and frequency penalty are also kind of very similar, I would say. You can also control the length of maximum output. Okay, and again, based on the platforms, some of these options might vary. But if you look at OpenAI, the Azure OpenAI playground, if you go to parameters, you can see that there is something called max response. You can control the number of tokens here. And you can also see the number of tokens. Can you see how many tokens? You can actually see the overall number of tokens that is kind of getting selected. So your input, your output together, and you can see the total number of tokens that have been used so far. Okay, and you can also clear, in case you want to clear your chat, you can do that. And you can once again start typing, and you can see the total number of tokens, right? And this is approximately the number of words. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so the tokens it's not exactly the number of words. They also take into account punctuations and symbols, but it's approximately the number of words. And you can see right now, since I cleared the chat, you can see if I hover over it, the total number of tokens that the GPT-4 Omni model can accept is 128,000. And out of that, you can see that 11 tokens are already used up. Why? Because they are part of my system message. And this is a very, very important thing to keep in mind. Whenever you're making an LLM API call, this entire thing is sent as an input. The input is not just what I'm typing. Okay, this part is very important. So when I give a user input, so let's say if I ask, what is the usual weather in Delhi? I'm not asking the live information. I'm just generally saying, based on the GPT's information, what is the usual weather in Delhi during summers? So this is the input token. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9. Approximately 9 to 10. 10 is going to take the. I told you it's going to take the punctuation also into account. So you can see that's actually 11 from the system message. Can you see? You can see the system message is 11. It shows 11. And it's plus 10 from the user message, and total we have used up 21 tokens. So user query is actually 10. So total 21 tokens we have used up. And if you just run it, you'll see the output tokens will also get generated. And total, you can get an idea as to how much tokens are getting used up. Okay, you can see that overall, out of 128,000 tokens that the GPT-4 Omni model can use, I have already used up 303 tokens. And you can see that here, out of it, the system was 11. And very, very important, the message history was 291. What is the message history? The message history basically is the entire thing, the user plus the assistant combined, because this is the contextual window. I can continue entering new queries, right? Okay, so this part is very, very important. So now if I go and ask the question, what is the temperature usually during winters? usually during winters, if I ask this question, I will not run this now, but I wanted to quickly talk about what is exactly happening behind the scenes. So what is exactly happening behind the scenes here is that we are going ahead and taking the system message. We are using the system message. We are combining this with the user message. This is the user message, I think. So we are combining the system message with the user message. And remember, we don't have a single user message. We already have a user message here. I will call it U1. And we have an assistant response here. I'll call it A1. So we are combining the system message plus U1 plus A1. Mind you, this is all of these are strings, right? Because everything is like text. Text is nothing but string. So we are combining the system message with the first user input, with the first assistant response, and then we are adding the second user input. The second user input is basically this. The second user input is basically this. This is the second user input that you can see on the screen. This entire thing is what is part of my prompt. And to add to that, we have parameters. These are the parameters I was talking about. And I'll show you the parameter section a bit more in detail. There's a whole lot of parameters we have here. This is where you can give your temperature, your uh, top P, all those kinds of parameter settings you can give. And this entire thing is what constitutes your prompt. So the prompt is not just the system message. The prompt is the the system message, and you need to do a lot of work to write a high quality system message. You have the entire historical context. See, that is how it is calculating the total token. See, it is calculating the historical context. So all the messages that were exchanged before, that entire thing is part of my message history. System plus user assistant plus user, the new user input. This is what we will use to make the API call. This we will send to GPT. We will make the API call, and based on that, the model will generate the assistant response A2. And I will show you how the A2 response looks like now. I will show you how the A2 response looks like now. When I run the code and when you see the A2 response, you'll see this is what the model responds now, A2. See, the number of tokens will increase now. See, it will actually increase. Out of 128,000, now we have used up 590 tokens. The message history is 578. And now I can ask a follow-up question. Should I travel there? I'm just generally asking you, okay? And now what has happened? What is the history now? What is the history now? So U2 plus A2, assistant gave a response. And now I'm asking, what is this? This is U3. This is the U3, the third user input. And based on that, the model will generate assistant response 3. So you get the idea how in a sequential chain we are doing it, right? And this is important because an API call is stateless. It does not inherently remember what you gave it before. You have to explicitly give that information as part of your prompt. The language model is just an entity. It's just sitting there. It doesn't have memory by itself, right? So all that memory management is something that you will have to do. So in an API call, while you are making an API call to the language model, you have to explicitly specify what is the system message, what is the broad behavior of the system, what happened until now, user assistant, what happened until now, and you will have to give the final user query that you're asking right now. Okay, and this is a very important workflow that I wanted to kind of cover. So a lot of people kind of keep asking and keep thinking that, hey, how is it that the language model is remembering? How is it maintaining the conversational history? This is how it's doing that. And actually, GPT-4 is not one of the best models in terms of context window. GPT-4 is still a very basic model, I would say. If you look at models like Gemini, Gemini is a much more advanced model in terms of context window. Gemini's context window is more than 1 million. Gemini has a more than 1 million context window. Okay, the interface is very similar. If you want to see the interface, so Google has something called AI Studio, right? So it's the same way that we are discussing all these things. See, after a while, when you learn these topics, it will be very easy to go and experiment with other kinds of things. Like you can go to something called AI Studio. It's very similar. Can you see? I am right now using the Gemini 2.5 Pro model, which is the most advanced, one of the most advanced models that we get. Okay, you can get an API key, all that you can do. And similarly, you can also see the template code. You can see the idea is very, very similar. The same thing. See, only thing is that in case of Google Gemini, the initial instantiation part will be different. You have to give Gemini's API key, but see this part is exactly the same. You see, user message, system message, very, very similar. And even the parameters are also very similar. System settings, see the spot like top P, temperature. So all these settings are very, very similar. So all the large language models, because they are inherently based on the same technical ideas, they all share the same characteristics. So when you learn a GPT, you can easily go and apply this in any of the language models that we have. Okay, there are ways you need to control that. You need to control that. So what is usually done is, if you're building a long application, and it's a good question. So the question is like, if you're building a chat application, and obviously the chances are very high that you will cross 128,000 tokens. And because the context window is small, then how do you manage it? One very common way we do it is we summarize. We keep summarizing in chunks. See, right now that is not happening. So let's say we can. This is again a complete management that you will have to do. You will have to do the memory management. So you will look at let's say the last 10 messages. And when you get the last 10 messages, what you will do, you will summarize those last 10 user assistant interactions, because that is how we are saving, right? UA, 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 UA. So once you have those 5 pairs of UAs, what you can do is you can summarize it. And then that summary is part of your user message. Got it, right? So that becomes, so that's how you have to do it. You have to continue summarizing it. Yeah. But context window is always an advantage. If you that's one of the reasons why, if you look at something like a Gemini, Gemini performs very well with large documents and large code bases. Even the Cloud A Sonnet model has a very, very high context window. That is one of the reasons why the GPT models are not very good in coding. I mean, obviously, in the benchmarks they do well. They're all similar. But if you really look at competition and how they perform on code bases, large code bases, the Anthropic Cloud Sonnet models do very well, because they have a very large context window. So you can literally take an entire code, like I was showing you Cursor, Windsurf, some of those real platforms. They all use Cloud Sonnet behind the scenes, okay? And reason is because the context window is very high. Even if you take a huge code base, the model can still remember a million tokens. And million tokens is huge. I mean, that's still a very, very huge thing you can upload, and it will still remember what was the first part of the code and what's the last part of the code. Yeah, yeah. Yes, that has to be done. You don't have a choice, because you cannot exceed the number of tokens. If you exceed the number of tokens, it will be an error. You cannot. Yeah. The API will only accept a certain maximum number of tokens. Yeah. Right. So the idea is that when we use a pre-trained model, we are only working on the basis of whatever information or knowledge that the model had from before. That is the idea. So we are only looking at whatever information or whatever knowledge the model basically had from before. So that is the whole idea of using a so-called a pre-trained model. But when we talk about an agentic system, a typical agentic system, if you see, so what is this agentic system? Agentic system is when we use a web interface like a chat GPT. Think of that as a kind of an agentic system, right? Because that is also based on a pre-trained model. So behind the scenes, that is also based on a pre-trained model, but it is also able to access the live information. So at a very basic level, we will again cover this day after in a lot of detail, but what is the main difference between a simple large language model and a typical agent? The difference is with respect to that an agent is not just an LLM, it's LLM plus some integrations. So for example, the chat GPT has integrations with many other things. It has integration with search. It has integration with search, live search. So if I ask the question, what is the weather in Delhi? What is the weather in Delhi? You can see it will actually give me the real information. So it is not just a pre-trained model, it is a pre-trained model plus integrations. And integrations not only with the web, this is a search GPT, integration with web and other external things. External things could be, it could be a database, it could be a some other file system. That's why agents are so powerful. Underlying the brain is still the language model, but the language model is able to work, you know, along with a lot of other systems. And we'll see this in detail, right? I hope the general idea is clear what it is. Okay. Okay. Any other questions? All good? All of you are getting the idea what is it? I mean, so this a very, very important part we talked about was the API call. So we talked about what an API call is. So system message, user assistant, how the history is getting maintained, how you're able to remember what, because all this is part of the prompt. And if you go back to your view code, you will see this entire thing is part of the flow, right? So system, user assistant, user assistant. So next time when you go and you write something in the code, you will also have to maintain this entire thing. So every time you make an API call, this whole thing is part of the prompt. So the history is already part of your prompt in terms of user assistant messages, right? And this is where you can set your prompt parameters. This is what we talked about. You can also set the max response. You can set your temperature, right? And these are all system level settings. And next time when we talk about a prompt engineer, because this is the other question that keeps getting asked. So what exactly are prompt engineers doing? So what is it that prompt engineers are really doing? So next time we talk about prompt engineers are doing this only. Prompt engineers are basically looking at the entire text. They are looking at the entire use case, and they are trying to generate the ideal prompt. In a way, that is what prompt engineers are trying to do. They're trying to curate the ideal prompt. So what is the ideal prompt is what they are basically trying to curate. So even for this use case, you can see there are different system messages you can create. There are different parameters you can create, and you will spend a lot of time doing this. You'll spend a lot of time curating the best system message, the best prompt parameters, and once you do it, that's it. You deploy your application, you clear your chat, and this is what the users will see. The users will have no idea what is your system message, what is the parameters, but that is what as a developer you are doing. And once you have uh, finalized your system message, once you have finalized your prompt parameters, that's it. That's your application now. And as a user, all I will do is I will just type my user query. Will I travel there or whatever? I'm just generally typing something. And what is going to happen when I hit enter is when I hit enter, my user message will be sent along with the hidden system message plus parameters. I have no idea what that is, but that is how the API call is happening, right? So there's a system message. There are some prompt parameters that is being combined with my user message. So system plus user plus parameters, that is my complete prompt, and the assistant response is going to come. So this is the way how the entire API call is happening, even inside the GPT playgrounds and all that we typically see, right? I hope everyone's getting a sense of what's happening here. Okay. So now what we'll do is we'll try to get into Jupyter notebooks. All this while, it's been a pretty robust introduction to what these things are, and now we'll get a little deeper into the notebook part. And first, we will look at a little bit of the Jupyter notebook setup. I will share some of the files with everybody. So the kind of notebooks I'll be using, I'll share a drive link, and we'll start our first demo using the Jupyter notebooks here. Okay, and we'll see this in action. So far we've just been discussing connect to the API, but now we will, for the first time, we will actually do it in code.